So to start with our linear programming word problem, we had to pick 4 lattice points. So these are our lattice points. So each X is the number of sour lemonade servings and each Y is the number of sweet lemonade servings. So basically we chose 4 lattice points, all with decreasing slopes. So by consecutive points, we made lines. So for the first line, it would be y equals negative 1/2 x plus 500. The next line for these 2 points is y equals negative x plus 600. And then the next line for these 2 points is y equals negative 3x plus 1200. Then we will turn these lines into our constraints for our word problem.
The Lemonade Hut is selling lemonade at the Baseball College World Series. Their sour lemonade costs $4 per serving. It requires 1 cup of sugar, 3 lemons, and 1 tablespoon of their secret ingredient per serving. Their sweet lemonade is $2 per serving. It requires 2 cups of sugar, 1 lemon, and 1 tablespoon of their secret ingredient per serving. How many servings of each kind of lemonade can they sell to maximize their profit if they only have 1,000 cups of sugar, 1,200 lemons, and 600 tablespoons of secret ingredient?
After reading the word problem and taking the equations from before, we wrote some constraints. This is a constraint for the sugar. The x still equals all of the sour lemonades being sold, and the y equals all the sweet lemonade being sold. Then we have lemons, and then our secret ingredient. And we also had to include x is greater than 0 and y is greater than 0. So we don't have any negatives. Also, after reading the word problem, we came up with our objective function. Since the sour lemonade is sold for $4 and the sweet lemonade is sold for $2, that is going to represent our max profit.
In our constraints, we found our x and y intercepts for each line by using slope intercept or x and y intercept. And then we shaded the region where
To find our feasible region, we want to find our vertices. So here are our vertices, and you plug them in to our objective function to find out our max profit. So as I did, we plugged it all in, and we find out that this vertice of the feasible region works the best because it gives you a max profit of $1,800. So our answer would be the Lemonade Hut has to sell 300 servings of sour lemonade and 300 servings of sweet lemonade for a max profit of $1,800. Okay, so for our word problem for a system of linear equations with 3 variables, Monica decided to divide a total of $42,000 into 3 investments. So one of the investments was a savings account paying 5% interest. Another was a time deposit paying 7% interest. And another was a bond paying 9% interest. Her total annual interest from the 3 investments was $2,600. And the interest from her savings account was $200 less than the total interest from the other 2 investments. How much did she invest at each rate? Well, to start off, our variables, S stands for the money invested in the savings account. The T is the money invested in the time deposit, and the B is the money invested in the bond. So since she divided all of her $42,000 into 3 separate accounts, we do S plus T plus B equals 42,000. Since she earned, we wrote this equation, and since it's percents, you have to do it in the hundredths place. And then it says that her the interest from her savings account was $200 less than the total interest from the other 2 investments. So the other 2 investments were the time deposit and the bond. So we did the interest percent plus of the time plus the interest percentage of the bond equals. And then since the savings account was $200 less, we did 5% 5% from the savings account plus $200. And then we also will go on to multiply it, the last two equations, by 100 just to get nice, easy numbers to work with.
To get the new equation number 1, we first subtracted 5s from this equation over to this side. So we get negative 5s plus 17 plus 9b equals 20,000. We then added it to this to eliminate the negative 5s. So we ended up with 14t plus 18b equals 280,000.
Alright, and then to get our second new equation, we multiplied the top equation by 5, and then we rearranged the bottom equation. So then the 5 would already be negative, so our s's would cancel out. So then you would get 12t plus 14b equals 230,000.
Okay, so now that we have our two new equations, we want to use elimination on them to solve for b. So for this equation, we're going to multiply it by 14. And then for our first new equation, we're going to multiply it by negative 12 so that we can cancel out the t's. So for this equation, it changed to negative 168t minus 216b equals negative 3,360,000. And then this equation, when we multiply it by 14, we got 168t plus 196b equals 3,220,000. So when we cancel out the t's, we get negative 20b equals negative 140,000, and b would equal 7,000.
So just found out what b was. We're going to plug it into new equation number 2, and we get 17t plus 14 times 7,000 equals 230,000, and we get 12t plus 98,000 equals 230,000, and then we just get 12t, and we're going to subtract 98,000. Then we get 12t equals 132,000 for a final answer of t equals 11,000.
Alright, so since you already found out what t and b were, you can plug it into your first equation, which was s plus t plus b equals 42,000, and you would subtract 11,000 and 7,000 from 42,000 and get a total of 24,000 for s.
Your final answer will then be she invested 24,000 in her savings account, 11,000 in her time deposit, and 7,000 in her bond.